Photo finish. Speedy is the star runner of her country's track team. Oh, cool. Among other events, she runs the last 400 meters of the 1600 meter relay race. Ooh, 1600 meter is a mile almost. And a relay race is where each person runs one lap, and one lap around a track is 400 meters. A sport analyst studied the video of one of Speedy's races. The analyst came up with this formula to describe the distance Speedy had run at a given time in the race. So Speedy's distance as a function of seconds is 0.1 t squared plus 3t. Cool. Cool. We like formulas. Okay, in this formula, m of t gives the number of meters Speedy had run after t seconds, with time and distance measured from the beginning of her 400-meter segment of the race. Although this formula might not be very accurate, treat it as if it were completely correct. Okay, that's a great note. 1. How long did it take Speedy to finish the race? That is, how long did it take her to run 400 meters? Let's see, well, we know that if she ran 400 meters, then this function would equal 400. So let's see what we can do with this function. Let's see, 0.1 t squared plus 3t. So m of t is equal to 0.1 t squared plus 3t. Okay, and we know that by the time this race is done, that will equal 400 meters. We actually have right here something that's hard to solve for the correct time. What we could do is we could plug in some times, like if we made an in-out table, where in was our time and out was our meters as a function of time. Let's try that out. Generally it takes people, let's try 50 seconds. 50 seconds to run a 400-meter dash, to run a segment of a 400. And that's a pretty good time, especially for high schoolers. But this is the country's best. So we'll see if it's too much. If our out number is over 400, then we know we've gone too high. So let's try 50. So 0.1 times 50 squared plus 3 times 50. Oh my gosh, you all, I'm a genius. I promise you I didn't even know that before. Okay, we just found the answer. Right, it's equal to 400, so we know 50 is the answer. Wow, oh my gosh, how nice is that? I was gonna actually have us do an in-out table where we couldn't find the answer, and we had to use the quadratic formula to solve this. So there you go. Lucky guess, I'm not going to do that. Wow, and you all skip a quadratic formula lesson. Guess and check. No, just kidding. I'm going to show you it anyways. We can use the quadratic formula, which maybe you're familiar with it, maybe you're not. But if we set this equation up right and we have it 0, if we take the 400 away from both sides, and we have 400 minus 400 is 0. And we set it up in our quadratic formula format, t squared plus 3t minus 400. We can solve for t using this formula. Oh, I might even have to look it up. We know that t is going to equal b, let's try it and we'll see if it's right. B squared minus the square root negative b minus the square root of b squared minus 4ac all divided by 2a. Okay, now I'm paranoid. I don't know if I got it right. The quadratic, whoops. Uh-oh, come on, phone. Quadratic formula. Let's see if we got it. Negative b, plus or minus b squared minus 4ac all over 2a. We got it. Okay, wonderful. What do these letters mean? They're the coefficients in front of our terms, which is why we had to set it up in this specific order, where in front of your squared variable is a, in front of your variable that's not squared is b, and in front of your constant at the end here, that's going to be your c. So we can plug this in. We're going to say this is equal to, let's see, negative b, where b is 3. So negative 3 plus or minus the square root of, let's see, 3 squared. 3 times 3 is 9. Actually, I'll just write out 3 squared for now. Minus 4 times a, which is 0.1, times c, which is negative 400, all over 2 times 0.1. Kind of messy, huh? That's okay. Let's power through it. The quadratic formula is often messy. Okay, I'm just going to work through this and see if we can simplify that thing that's under the square root. So negative 3 plus or minus the square root of, let's see, 3 squared is 9. Then, okay, we know a negative times a negative is going to be a positive. Then I'm going to just multiply all these three things together in my calculator. I think it's going to be 1200. Let's see. 4 times 0.1 times 400. No, it's going to be 160. There it is. Okay, great. Plus 160, all divided by 2 times 0.1, which is like 2 divided by 10, so 0.2. Okay, it's getting a little bit better. Now we've got negative 3 plus or minus the square root of 169 divided by 0.2. Okay, then let's see. We actually, if you might have this memorized, but 169 is a perfect square. 169 is the square root. The square root of 169 is 13. So that's fun. Usually often your square rooted number can be pretty messy and irrational with decimals. But now we've got 3 plus or minus 13 divided by 0.2. So now we've got two answers. We've got our plus answer. We've also got our minus answer. Let's see. Negative 3 plus 13 is going to be 10 divided by 0.2. Negative 3 minus 13 is going to be negative 16 divided by 0.2. Now, ready? So what we're doing is we're solving for a time, right? Our t is our number of seconds. One of these branches is going to give us a positive time. The other branch gives us a negative time. I don't know if you've ever been to a track meet, but they often don't record negative times, which means we don't care about this one for now. But we do care about this one. So we're going to move on to this top branch of 10 divided by 0.2. Oh my gosh, did I mess up my math somewhere? I may have. Well, I guess, what's 10 divided by 0.2? It should be 50. Ah, no, we're good, we're good. I didn't mess it up. Okay. And that's equal to 50 seconds. And that's how we found it. So we found it really two ways. Lucky, guess, and check, and then algebra, or the quadratic formula. Answer. So it's 50 seconds, and we found it an in-out table. Lucky guess. And we also found it with the quadratic formula. Okay. 2. The analyst photographed Speedy at the instant she crossed the finish line. The photo is slightly blurred, so you know Speedy was going pretty fast. But you can't tell her exact speed at the instant the photo was taken. Find Speedy's speed at that instant. Oh, we're pros at this now. Well, let's use the instant as the 1/100th of a second, like we've been using. I'm going to draw a little line here. And which means that we're going to want to take, what is it, m of 50, which is when she crosses the finish line. And we're going to want to subtract the distance she was at 49.99 seconds. Right? That's 0.01 seconds before she crossed the finish line. A very, very good estimation of our instant. And then we, of course, subtract the final time minus the time right before it. So we know that the meters here are going to be 400, right? Because that's the race she ran, 400 meters, minus, let's figure out what this is going to be. All we're going to do is we're going to plug in our time of 49.99 into this equation and substitute t. So let's do that. 0.1 times 49.99 squared plus 3 times 49.99. So that's 399 meters, 0.87, and I'm going to leave off the 001. Just for rounding's sake. So 399.87. Okay, and then we divide by this interval here, which is just 0.01 seconds. Okay, then if we take our 400 meters and subtract that, we get, we'll call it 0.13. And we know that when we divide by 0.01, it's like multiplying by 100, which moves our decimal over 2 places. So we're going to be at 130, and this is feet per second. So she's running 130 feet per second at the instant she finishes her race. That's so fast. But remember, the problem said to treat this as true. So we see at the instant she finishes, find the speed of the instant, that's 130 feet per second. Okay, so find speed at 3 other instants during the race. Was there an instant when speed was going exactly 10 meters per second? If so, when was that instant? Oh, that's a fascinating question. Okay, let's start off by finding Speedy's speed at other points in the race. So let's find her speed at the, middle. So at 25 seconds. And then we're going to find the instant before it. So m of 24.99 divided by 25 minus 24.99. Okay. Actually, I might skip a line and have that be underneath right there. So let's see here. We've got m of 25, so we're going to have to do 0.1 times 25 squared plus 3 times 25, which is 137.5, minus, and we'll figure out this, and I'm going to, well, I shouldn't have actually done that, 24.99 squared plus 3 times 24.99, and that's 137.42 divided by, that's 0.01. Then if we do 137.5 minus that number, that's the answer is going to be 0.08. And that's, of course, in meters per second. Did I say feet per second earlier? I totally did. This is in meters per second, which is even faster. And we're going to actually use this, okay, so then we move our decimal over 2 places. So she's moving 8 meters per second. Okay, so that's one instant. at 25 seconds. Okay, it looks like we're getting close to 10 meters per second, which is our next part of this question. So I want to move our time, let's say at 30 seconds. So m of 30 minus m of 29.99 divided by 30 minus 29.99. And let's do that. So then it's 0.1 times 30 plus 3 times 30 is 93 minus 0.1 times 29.99. Oh, I did that wrong. Clear, clear, clear. Second entry, second entry. This is 30 squared, right? 180. Then 0.1 times 29.99 squared plus 29.99 times 3, which is 179.91. And then that's divided by 0.01. And that's going to equal, let's see, I'll try and squeeze it in here. So if we do 180 minus the answer we just got, that's 0.09. Oh, we're getting so close. And then if we divide this by 0.01, we're just moving our decimal over 2 spots. So that's going to be 9 meters per second. Okay, we're getting close to 10. Should we just go up another 5 and see what happens? So let's try 35 minus 34.99 divided by 35 minus 34.99. And let's see what that's equal to. So 0.1 times 35 squared minus 3 times 35 is 17.5 minus 0.1 times 34.99 squared minus 3 times 34.99 is 17.46. Then divided by 0.01. I have to sneeze. Excuse me. Okay, great. Then if we do 17.5 minus the answer, we're at 0.4. What? And so now we're back down. Wait. Our number went down. Did I mess up? So 1.1 times 35, 3 times 35, 34.99, 3 times 34.99, 17.5 minus 17.46. Whoa, what's the deal there? Well, okay, so now we're at 4 meters per second. But is there a time when we're going exactly 10 meters per second? If so, when was that instant? Oh, I'm getting hot. And this video is getting long. How can we find that out from the information we have? Well, I feel like there's got to be. What if we try? Let's try a number closer to this M30, and if we can't get it this time, then maybe we'll graph it. Okay, so let's try m of, let's try 32. 31.99 divided by 32 minus 31.99, and that's going to equal 0.1 times 32 squared plus, oh, did I do minus earlier? I did do minus. It's supposed to be plus. I totally did mess up. Okay, let me double check these numbers. So, clear. So is it, oh. I'll just replug them in instead of looking for them. Okay, so 35.1 times 35 squared plus 3 times 35. Ah, that is a much different number. Yeah, I should have known that this looked funky. So that's all wrong. So this is going to actually equal 227.5 minus 0.1 times 3499 squared plus 3 times 3499 is 2227.40. Oh, I think we found it actually. Divided by 0.01. Then if we subtract these two, 227.5 minus our answer we just got, round that up to 0.1. 0.1 divided by 0.01. And then we just move our decimal over 2 places because of that, so which is equal to 10 meters per second. What a lucky guess. We figured it out. At 35 seconds, Speedy's running 10 meters per second. Let's answer that. Ugh. At 35 seconds, okay, thanks for watching.